And then we also have Kelly, who's going to talk to you about career opportunities at the Home Depot.
Hi, everyone. So happy to be here. Y'all are in for such a treat today. My name is Kelly Seibert, and I support the e-commerce data science team here at Home Depot and get the pleasure to work with Jackie, Estelle, and Becky on a daily basis. So really excited for you guys to hear from them, but also wanted to make sure that everyone was aware of other data science and analytics career opportunities across Home Depot. So we do have a very impactful and powerful e-commerce team, but outside of our online data science team, we also have representation across the enterprise in space optimization, supply chain. We have enterprise technology, finance, marketing, merchandising solutions, and human resources. So we have grown consistently across the organization, all of our data science and analytics practices. So definitely wanted to make sure that you all were aware that there are opportunities also outside of online data science if your interests are in those specific areas. We also have a place in Austin, Texas. It's called Black Locust. You may have heard of Black Locust if you're here in the States, but it is a former startup that we acquired several years ago. And their intent, they focus around building retail technology and helping drive critical business decisions for Home Depot. So we have another arm of data science that sits in Austin, Texas as well. So I believe Claire or Women Who Code will be dropping my information in the chat as well as our career opportunity links. So I am here and always happy to help. Again, my name's Kelly Seibert. You'll have my email, and again, happy to tackle any questions. And we hope that we can drive your interest in Home Depot. And without further ado, I'm gonna pass it along to our awesome guest speakers.
Sapphire, I think you're on mute.
I think my mouse is also running out of battery. Thank you very much, Kelly, for that. And now we're going to start off with fireside chat with Estelle. So Estelle is a senior manager of the data science team based in Atlanta, USA. And she joined the Home Depot 7 years ago, and her major contributions are to the core e-commerce functionalities with optimization of the internal search, the development of recommendation algorithms, and now growing the visual artificial intelligence capabilities to improve overall online customer experience. So I'm going to stop sharing my screen so we can speak to Estelle and get the proper panel up of us. Okay, so awesome. I'm just going to remove a few panelists so we can get the screen up of the three of us that's going to be speaking to Estelle today. There we go. There. Okay, awesome. So Estelle, please introduce yourself and tell the audience your background and career path that led you to the Home Depot.
Thank you first for having me again. I'm super pleased to speak for the second time in Women Who Code. I think it's a fantastic, organization. I'm happy to volunteer here. But shout out first to Sapphire, Naomi, and Srishti for holding this session, and everybody behind the scene who is really making it happen. So it's an honor for me. So Estelle Afshar, I am from France, but I've been in the US for about 12 years now. 8 years now in Home Depot. My anniversary was in January. And I have the privilege to lead a team called Visual Artificial Intelligence for the past 2 years within Home Depot. It's, I will talk a little bit more about the team later, but how did I end up here? As I mentioned, I'm from France, and my interest initially was biology. So how did I come up into data science and artificial intelligence? It's a journey, not a straight journey, but I came to artificial intelligence through biology, more particularly through computer vision to analyze microscopy images. And once I got that bug, that means the virus of learning more and more and wanting to leverage more of the machine to do not only things that the human had a hard time to do, but sometimes what human couldn't do, actually detect very very subtle nuance within the composition of biopsies. So I came through academic work into artificial intelligence. And I would say that at some point, I switched to industry, and Home Depot gave me that opportunity, and many opportunity within Home Depot. So happy to talk more about this, but this is how I ended up, growing from data scientist to senior data scientist to now leading a team.
Thanks, Estelle. We're super excited to have you again. It's always good to have a chat. We love having you here. So you were saying that you're a data science manager, data science senior manager, visual AI at the Home Depot. And just for folks that are, a little bit curious, like, what does that mean to have that job? Can you tell us a bit about that and about your team?
Absolutely. So first, being a senior manager, meaning that I am in charge of driving the team. Number one is being recruiting talent, not doing that job alone. As you see, there is a team behind me who is helping. So recruiting talents to build and to build a vision and actually execute. That means really create, the product that we are envisioning. So visual AI in particular, we are focused on creating visual experience for our customers for the online website, which goes from desktop to mobile web to apps. So how do we do that? We have really three main directions. The first one is to improve the visual aspect of the website. So by doing that, how do we do that? Is by making sure that we intentionally use certain images in certain places. So for example, when we are using images for marketing, it's going to be more toward inspiration. While we are, selling lumber or pipes, that's going to be more around, the specificity of that product. So we will need, very much a close look at the product. So this is a way we are voluntarily, deciding which image to use where. But we are also emphasizing and enhancing the images that we already have by adding, for example, the dimensions on the images to help customers to better understand what are, the width versus the depth of a given product. Finally, we also create, by combining existing images, an experience to sell a bundle. So if we want to sell together a refrigerator with an oven, with a microwave, we with image analysis are able to combine these images to create that experience. So this is the first direction. Second direction is very much towards recommendation. Part of our catalog in Home Depot is around furniture. So these products are both typically around how they look, what color they have, what style. So it fits with the taste of the customer. So to drive this, we have within recommendation the opportunity to give to the customer a broader choice to view products that look similar to what they are looking at. So really they can refine, exactly what they are intended to purchase. So visually similar is specific to furniture, which is very different than, again, lumber or pipes, where here what's similar is based on the functionality, on the dimensions. For furniture, what's similar, it's not because it has necessarily, the same dimension or the same fabric, but really because it has the same, feel, the same look. And for this, we have leveraged images and, build deep learning models that are able to actually compare images and measure the similarity. Another example of recommendation is a more challenging one, which is what goes together. So now we have, we have an idea of, oh, I really love that couch. What goes with it? What kind of coffee table or hand table or rug should I, associate it with? So, it's kind of thinking about a virtual interior designer at scale. So what we are, how we are approaching this problem is through supervised learning, where we are learning from existing collection what goes together, and try to, by feeding this information to different models, try to really learn the patterns of what goes well together. My third direction in the team to drive, again, visual AI is to create interactive experience with the customer. So this is just nascent, but aiming to grow. The first experience I'm going to talk about is helping customer to choose which color they want to repaint their room with. Not an easy choice, though. Once you are in the middle of painting and you realize it's not the right color, you wish you had, better insight earlier. So what we do is we offer the customer to take a picture of their room and pick the color they want to see how they would look like. So this is a real-time application. That means they can do it from the tip of their fingers on the app, take a picture, choose a color, and see how it will look like. So these are the three, again, directions that visual AI is being driven in this organization.
Awesome. Thanks, Estelle. It's really interesting hearing more about the team you lead and what you all do. So as we mentioned earlier, data science spans the organization. Can you highlight the different fields of our online data science team, and how do the groups collaborate with each other?
Yes, absolutely. So we have a broad range of actually teams and functions and applications within online itself. So online encompasses, both marketing and the website to really serve and help customers, hand to hand. So that encompasses, search, recommendation, which are obvious on the website, but it's also optimized around personalization. What do we know about this customer that can help us to create a better experience? So if we know, for example, that the customer is a pro customer, we're going to emphasize on what are the materials that are needed for the pro, or the qualities that are needed for the pro, or the quantities that are needed for the pro. So personalization is also a big theme. And beyond that, it's really range from, from building models to, reporting performance and being able to identify what are the next opportunities, exploring, new technologies as well to create the experience of tomorrow. Segmenting our customers into, again, segments that would help us better serve them. These are, or the range that we have within online. Now, data science, spreads way beyond our online organization, and it goes through, supply chain, store optimization, to know where to place the products in a, again, more efficient way for customers, to, black locus, which is more around, price optimization. So wide range of things. Kelly mentioned it. I think within data science, we cover many, if you have knowledge in data science, is likely a position that you could serve in Home Depot. I can only think of areas such as really, automated vehicles, where right now we don't have this opportunity in-house, but it might come.
Thanks, Estelle. That's a really good overview of kind of what's going on. I've chatted with you before about your career, and I love your path and your journey. So just like thinking about your career yourself, can you tell us about a key moment for you that shaped how you work today?
Yes. So I think You know, when I joined Home Depot, there was no data science team. So I joined as a product manager for internal search. And my responsibility was to improve the relevancy and retrieval of products. But I learned a ton during this first 2-3 years in Home Depot as a product manager, because it's really the role of building from the vision to the implementation, and partnering with key contributors, which are the UX, which is usability, UX designers, engineers who know the system where actually the algorithm needs to fit. It's fantastic to have a great algorithm, but it needs to actually be implemented in production. So from this perspective, and really when I joined, and I have no clue what a product manager's role was, I really learned while doing it. And it's very much skills that I use on the everyday basis till this moment. And I also thought and still think that it's a dream job in terms of being able to identify what are the opportunities to improve one area of the customer experience and really dedicate your full soul to it. It's not an easy one, but it's a fantastic job to have. Definitely something very different than what I had experienced, in academia. So that was a good key moment that defined my current career.
Thanks, Estelle. I found your career journey so inspiring, and it's so good to have you back speaking today. But can you tell us about, I always love to hear about challenges. So can you speak to the challenges of changing industries?
Yes, as I mentioned, my previous experience before Home Depot being big corporate in the US, I was mostly in academia, and I had also worked for as consultant for startups, but that were still around, and the purpose was still around building better model, higher performance, and being able to have some novelty in it, so it could be claimed as doing better than the solutions that were there before. Very different from, again, Home Depot being a huge corporation. The first, I think, challenge was just the business vocabulary, very different from what I was used to in data science. Again, I had no counterpart to talk to at that time. They were all speaking the same language, which was foreign to mine. Not just foreign because it was English, but foreign because it was business. So the goals and objectives were different, in business. So I had to learn this. The objective, again, were not, toward, building something new, but were toward, finding solutions. And really what I learned early on is they don't care about which model you're using as long as it works. And the simpler, the better, because it will help actually to move your solution all the way to production. So, the 80-20 rule also works very well, which is just, find a solution, even if it's only solved for 80% of the problem. We're not looking for, going from, like in academia, from 92% to 93% of accuracy. Here we are talking about making the difference on a pain point that many people are facing. And if you can solve for 80% of them, you're good. Move forward with this. We will have time to refine and reiterate on a second phase to solve problems if we think that actually solving for the other 20% is important versus tackling another problem. So priorities is definitely something that was new when coming to business.
Yeah, that's really interesting. That's interesting difference. Myself, I've always kind of been in software engineering on the production side. and, you know, I've been moving over into AI and stuff, but coming from that production side sometimes bothers some researchers' accuracy. They get a little itchy. Right now I'm taking some courses to level up some skills, and I'm in that research academic piece, and it's like, oh, okay, let's get really precise. So there's definitely a huge difference there. You know, we've been talking a bit about your career and then, you know, some of your path. For you, I guess I have a question kind of about like what you feel that your values are that you kind of bring into the team. And how do you like ensure that those values and the company, Home Depot's values, are upheld by, you know, all the folks on your team as you're, you know, managing so many people across all these different kinds of work?
Yes. So Home Depot is actually a value-based company. That means it has defined, you know, these 8 values that we are driven, and our success and cooperation within Home Depot are built upon these 8 values. So one of them, for example, is entrepreneurial spirit, and that definitely, you know, my team and other data science teams are just living it on the everyday basis, because we have to think about solutions that might exist or might not exist yet, either in other industries or, you know, just in the world. So entrepreneurial spirit is just, you know, for specifically for my team, Visual AI, where, you know, with the advent of deep learning has definitely, you know, boomed in the past, you know, 5 years, and we're still in the growth curve. If we don't have this this gene about, hey, you know, keeping up with what exists, being able to transfer some knowledge that we gain, that we read or educate ourselves, you know, from one industry to another, you know, we won't be at the world-class level that we are at this time, and we won't be able to maintain it. So so that's, you know, it's easy, you know, to cultivate this, you know, within the team. It starts obviously, you know, from, you know, recruiting the talents that have that mindset, but cultivation of it is, you know, through defining the project and defining, you know, the objectives.
Thank you, Estelle. I know you kind of briefly talked about this here, but so for people applying for, you know, jobs in this field, what skills or qualities stand out to you about someone to excel in an online data science position?
Yeah, I have my my own, I would say, you know, ideal profile of what drives success for data scientists. So first off is, you know, a rigorous scientific mind. You know, data science is a science. So let's, you know, be clear on that and not try to deviate from that methodology. Now, data science being a science is also, you know, based on data. So we need a good understanding of the theoretical and practical aspects of, you know, machine learning or deep learning or, you know, broader skill set that are needed. You know, in my team, these are the two that we are using the most. Beyond this, you know, being a nimble learner, you know, is also, I mean, data science, we know that this field is evolving continuously. So we cannot sit and rest on what we have learned a couple of years ago. We have to keep up, and we have to be actors of you know, the evolution of data science on multiple aspects. You know, as much on, you know, building more advanced models than, you know, being more ethical or being more, you know, being aware of the biases, you know, from the data, for example, to be able to drive, you know, better outputs from our models. So nimble learners, and your organization is actually doing that, which is, being connected, building a community where we can speak through these opportunities and those, points that could really improve our field, and improve in the sense of adoption and trust by the users. So nimble learner would be second thing I'm looking for. Then I would go more around having common sense, being able to relate on, hey, we don't need to build model for 3 months before having initial results. We need to have a continuous look at what we are doing, and having and not setting us objectives which are too big, without having regular checkup and regular deliverable. So having common sense, being curious, being able to play in a team. Depending on the size of the organization, obviously, if it's a startup, at the beginning it's a one-woman driven business, and that woman does everything. But even if she's a single data scientist in the company, she would need the help and the buy from the partners, from the finance person, from the engineering person. So being a team player, absolutely crucial, regardless of how large is the team. I think these are the key elements. Now, for Home Depot, is having an e-commerce background necessary? Not necessarily. That means we have many people coming from different backgrounds, and we learn as we work. So my point here is we can transfer the knowledge, from one industry to the other. And it's something also I say to my children, your knowledge is the only thing we cannot take from you. You can move, from a job to another. You can move country. You can move. The only thing we cannot take from you is your knowledge.
Yeah, I absolutely agree. And for myself, keeping that top of mind, that we can move this knowledge about and apply it in new places, for me, that's one of the things I think is key in really creating diverse workforces that have different backgrounds. For yourself, do you have thoughts on what you think is important for companies to keep in mind in order to foster diverse workforces, inclusive, collaborative environments, thinking about women in tech and other things like that?
Yes. So depending on the teams, it could be, or industries, it could be more or less challenging. In Home Depot, we are lucky to have women represented at every level of the career or the ladder of responsibility. So having, seeing a woman being successful and having some, senior leadership role, help cascade that mindset and that, projection to everyone. So on that sense, very important to have a mixed panel when we are recruiting people. So we have, the feedback from the panel from every angle. And personally, I know when there is woman in a team, the team works better. So hope this knowledge is spread out way beyond our own walls, because it's true. So I mean, the research, it's supported by research. So we need to know how to diversify. We need to be aware that it could be a bias still in certain environments. So, how to fight this bias is by making everybody aware and taking action upon those.
For sure. Thanks so much, Estelle. We do have a bunch of questions from folks. Folks are really excited about what's going on here. So I'm going to try and dive in and let you know what people are thinking about. There are a lot of questions. Okay, this one This one is like pretty straightforward. What are some of the visualization tools that are being used in Home Depot for really great customer experience?
So we are building our own. So we have two sets, and that's like every company, you know, for each project, we have the option of developing our own tools internally or partnering with a vendor, another, you know, company to actually bring that experience to life. So if I take the example of AR, so augmented reality, for example, where you can, for some of our products, you know, look at them actually in your room in 3D. So this capability is served first, you know, by AR toolkits that Apple is providing. I think there's another open source for Androids. So here, you know, we needed the 3D models of the objects. So far, we have outsourced this element, but we are thinking about creating 3D models. I mean, we are exploring to see if we can create these 3D models in-house. So visualization, you know, for the Paint application, you know, we have developed our own. We're not leveraging anything, you know, commercial. We are really much developing our own tools.
And another question that's come up as you were talking about this, someone's wondering, how does the team handle model and data drift?
Yes, so we have, I think it's still not a mature area at this point, but we're getting better by having just a regular checkpoint of how the models are performing. The thing is, to do that correctly, you know, we need to modify the testing set. You know, if we are measuring the performance of our, you know, the existing testing set, obviously we are going to have the same performance as we had, you know, initially when the model was pushed to production. So we have to constantly, you know, that means for us, for example, if we have new collections of the catalog, or if we have a new category in the catalog that was not part of the, you know, training and testing sets initially, we have to revisit these two things to evaluate the model and compare the models among those, against those, sorry. So it has to be, it's not integrated in the sense that it's not automated. So it's still a manual process.
Thanks. Someone's curious if there are particular kinds of challenges you've faced or encountered during COVID-19. Seems pretty broad, but.
Yeah, well, we were lucky enough that the company had already a policy where we could work from home once a day. So in terms of transitioning to, you know, full-time working from home, I think we were fully equipped. The challenge that we are facing, again, my team being more towards the innovation part of our of the company, I needed to continue to nurture this. And how do we do that? My approach was to mimic what we were doing in the physical world, which means, you know, meeting for coffee chats or, you know, a hallway conversation into the virtual world. So as soon as we were, you know, grounded home, I should say, I created a space where on the daily basis we could meet and have these just casual chats. So sometimes it was, you know, the conversation didn't need to be professional because, you know, when we talk to people, you know, it's not, you know, we you know, a person is a person and the spheres are overlapping between the professional and personal life. So creating that space where there is open communication around any topic that could be brought to. So this is what we have implemented in my team.
Yeah, that's really great. I really appreciate that, especially with yourself being senior. Like, I started this job completely remote. So I onboarded remote, everything remote. And just being able to grab someone and be like, hey, you just want to talk? It can feel a little intimidating when you're not the most senior or you're new to things. So that's really, really cool that you were able to create that space. another question more about your career, but I guess it kind of applies to a few things. When you made, hold on. What made you decide to move from an individual contributor track to the manager track? And what do you enjoy the most about that role change? I think it's probably around that vision and execution piece, but I guess what made you make the jump?
Yes. So obviously that's, for me, was because I have more, I wanted to handle more projects. And that was a way to grow, actually, that's in that space. So if I want to, instead of tackling 1 or 2 projects, but I have ideas for 10, actually that role as a manager, senior manager, is actually helping me to reach that goal. It's so individual contributor, it has to fit your personality. It has to fit, what you feel good at. I'm super proud of our, HR team, who has really worked hard on building, with our feedback, a career path in Home Depot where both managerial and individual contributor paths could grow all the way till, very senior levels. And there is an equivalent of individual contributor for senior manager, for director, for senior director, etc. Again, that's because the team is getting more mature. But I understand that when the team is not mature and allow that individual contributor to actually grow in seniority while still being an individual contributor could be a challenge. Because then we are torn around between, hey, if I want to grow, it's only managerial, and I cannot push. So I would encourage to have that discussion, with your environment, with your company, to see if actually they could recognize a senior person with a lot of experience as an individual contributor. Doesn't mean that they are going to work in isolation. That means that their primary focus is on being expert in their field, and they can mentor others. There's no problem. They just don't want to fall into the management of people, which is it's, to say the truth, it's different skills again.
Yeah, for sure. Someone else was asking, you mentioned you started your career as a product manager. Starting with such limited experiences, how were you able to show your value to your team in the first 6 months? I guess this could be also, how do other folks do this, right?
Yes. So definitely, I was shadowing a product manager to do that. But really the goals and the metrics I was going to be assessed were aligned with the data science. That means, hey, improving search, query recognition by X%, decrease the number of queries that are no result found. These are the metrics I was going to be assessed against, were aligned with data science. So the rest is about how do you make it happen? For me to be able to drive these metrics or to show my value, I needed to coordinate with the UX and with the engineers to make it happen. So it's almost like finding the solutions for the problem and making it happen. So I was not assessed as number of project I was doing, or how much I was collaborating with others. If at the end of the day I could demonstrate that it was impactful for our customers, that was what I was measured and assessed by.
Yeah, that's super helpful to know. A little bit earlier, you were talking about, transferable skills and knowledge. And I think some of your top 3 are having common sense, being curious, and being able to play in a team. But we do have someone asking, just, if you don't have direct AI ML experience, like what would yourself as a senior manager, what would you expect as kind of skills for an entry-level role in data science?
So we have actually in my team, we have, a lot of variation in seniority, and Jackie can speak through it, but we set everybody for success, knowing where they are when they join the team. That means first, I need as a hiring manager to know what kind of talent I'm looking for. Is it more junior? Is it more of a senior? Do I need somebody with experience or not? If I'm opening a position for junior, I know that this person, will need some mentoring and will need to set the project such that they are broken into smaller pieces and having regular check through its progress. That's what I am expecting from a junior. From a more senior, I'm looking for more autonomy. So from a junior, what I'm looking for in the talent, absolutely, having in that case, the understanding and the knowledge, that the theoretical understanding is going to weigh more than the experience, because I know that they haven't yet applied their knowledge on data sets that are in the real life data set, real world, not just the one from a course, which are typically cleaned up, smaller in size. This, I'm aware of that, so I cannot expect somebody who is junior, who is just going to be able to handle or know how to handle a data set that we have in Home Depot from day one. So what kind of skill set I am looking for? Again, knowledge, good understanding of what the theoretical aspect. Common sense, that's for every level. If we are not able to, again, if the model is correct, the accuracy is 99%, I am opening my eyes very wide. This is not necessarily a good thing. My next question is going to be, what's your methodology? What did you use as data? So that's what I mean by common sense, is being able to read through the numbers, to interpret them, and step back and say, hey, is it realistic or not, what I'm finding? So yeah, I mean, we had many junior in my team who are successfully growing. Again, as a hiring manager, you know where you set your expectation, and actually it was intentional to open one or the other position.
Thank you so much. I really appreciate everything you've shared today. I think we're going to wrap up there. We still have a whole bunch of questions. Sometime later, I will share the first chat that Estelle had with us, because I feel like some of the questions are answered there. I'm going to hand it over to Sapphire, but it has been wonderful having you again. And we really appreciate all of the things that you are able to share with us. And yeah, I'm always blown away by how much knowledge you have across different areas. Your insights are amazing. Thank you.
Thank you so much. It's my pleasure.
Yeah, thank you so much, Estelle. I second everything that Naomi said there. It was very insightful, and we can see a lot of our attendees are blown away. Thank you so much for sharing all of that. So I guess I'm going to invite Jackie now to the stage, who is going to be doing our next talk. Hi, Jackie.
Hi, how are you?
I'm good, thank you. How are you?
Well, thanks.
Thanks for joining us again on stage. So everyone, Jackie is now going to be taking the next talk. So she's going to be talking about active learning for product type ontology enhancement in e-commerce. So a little bit about Jackie. So Jackie is a senior data scientist at the Home Depot with over 5 years experience working here. So she holds master's degree in data science from University of Virginia and computer science from Georgia Tech. And her current work focuses on search optimization and product attribute classification, leveraging deep learning, computer vision, and NLP. So Jackie, I'm going to now pass it on over to you. I'll stop sharing my screen. There we go.
Thanks. Hi, everyone. It's a great honor to present on behalf of our team the work we have done to improve the Home Depot search system. So specifically, we leverage the active learning framework to enhance product type ontology, and we published our work at the KDD last year. So active learning in the machine learning field refers to a learning algorithm that interactively select and label new data points to improve the models. We will see how that works in details later. And also a brief background of the conference. So KDD is one of the largest data science conference in research and industry field. And the workshop we attended focused on knowledge discovery and knowledge graph, including construction, application, and embeddings for knowledge graph, and is primarily for e-commerce and enterprise applications. Okay. And first of all, why do we care about product types? So the search engine of Home Depot online implements an entity-based semantic search. So specifically, if you look at the example, it first recognizes meaningful tokens from the queries. For example, when customer searches GE stainless steel range, we try to understand GE is the brand, stainless steel is about finish or material, and range is the product type that customer is looking for. And after that, we'll retrieve from our catalog the items that match the attributes to those recognized entities. For example, so all the three items on the right have matched attributes to that query. As the relevancy ranking shows, the first one is obviously a perfect match, and the second one and the third one has one mismatched attribute, while the second one is about the color, and the third one is matching the wrong product type. So however, if you look at the last one, it's the least relevant and it provides the worst customer experience because it actually missed to understand the product type that customer is looking for. And as we can see from this example, product type is a more important concept than others, like material, brand in this search matching scenario. And we need to create and maintain a comprehensive and accurate product type ontology to support semantic search, which leads to the focus of this work, that is, how can we discover product types in an efficient and a scalable way? And I will talk about what product means and the challenge we have faced later. What is the product type exactly, right? So that's the fundamental and also the most complicated question we're trying to answer since the very beginning. So product type can be defined from the demand side, meaning from the customer side, as the atomic keywords or phrases that indicate what a customer is looking for. So when you walk into Home Depot store, you must have something in your mind that you want to buy or ask a store associate about it. That's the one definition of product type. For example, I need to find a new refrigerator, and here a refrigerator is a product type. Where from the supply side, we can see that product type adds a semantic tag that uniquely identifies a product, and we can use that tag in catalog organization. So for example, all dryers are grouped together in the appliances category, and all drills are grouped in the tools category. So apparently there's not a specific concept or it's not a formal or clear definition of what product type is. And because of that, it causes lots of difficulties when we're trying to determine if a phrase is a good product type produced by an algorithm. And if you look at the example on the right, we order some potential product type phrases from broader sense to more specific ones. And it's usually easier to make decision on the two ends of the spectrum, either too broad, more like a category appliances or tools or cleaning, or on the other end, like black rubber carpet for garage, which is too specific. And the phrases in the middle are more challenging, like utility sink is a good one, as it actually distinguishes itself from a standard sink in its usage. However, if you look at another example, cordless drill, we don't think that's a good one because cordless doesn't change the core functionality of a drill. So we're considering coord list more as an attribute instead of a standalone product type in this case. So due to such challenge, it is necessary to bring in domain experts when we make judgments on those ambiguous cases. So one of the challenges, as we can see here, it requires manual effort to actually determine a good one or bad one, and labor is really expensive, so we have to make it more efficient. And here is the framework we're proposing. So we leveraged active learning framework. That way we can efficiently utilize domain experts' knowledge for product type discovery and classification. If you look at the chart on the top, on a high level, it starts with a list of candidates that could potentially be valid product types. And only a small portion of them are known and validated. If you look at its known product types over there. And if you look at the first table of the examples on the bottom, only hammer and dryer are existing product types. And we then train a classifier by some special sampling strategy. And the trained classifier then gives a confidence score to every candidate about how likely it is a valid one. And the top ones, which in this case are kitchen sink and gray wall tile, will go to domain experts for manual labeling. And feedback from domain experts is then used to update the label. If you look at the third table, and we update the label, and this updated data will be used for next round of training. And such process will repeat for a certain number of rounds. And this is how we refer to as active learning, where for each iteration, we interact with the human and we update our labels. And to understand some details, so we know we have some candidate pool, right? And where is this candidate from? So there are two major sources we're using in this case. First one is the frequent search queries. So it's based on the assumption that a regular query should contain the product type information, with some exceptions like a brand search or product ID search. We actually verified our assumption by looking at the most search queries, either globally or within a particular category. And we confirmed that those top searched ones are all good product types. In other words, those common search queries have a high precision, and it's a good source of the product types we are trying to discover. However, the shortcoming is that it is biased towards the popular products and categories, such as drill, ceiling fan, washer, and it actually fails to give us a more, it fails to tell us what are some last used phrases. So that's why we include another complementary source from catalog, like product title or descriptions, to discover those less popular ones. However, it requires additional phrase extraction model, and the extracted phrase sometimes are not necessarily about the product type, which means it introduces more negative or noisy cases. But it does a good job covering things like plug fitting or battle filter that are less frequently searched by customers, but it still brings business values as we use that for multiple applications. And so if you see the words phrase mining here, so it is the process of automatic extraction of high quality phrases. And those phrases can have some special meanings, like it could be an entity name, it could be a scientific term, and it is given in a specific context or corpus. And we use a framework called autophrase. The link is provided on the bottom of the page. And this method uses positive only thesis training and the part of speech tagging guided phrasal segmentation. Now we have the candidates. We're ready to construct a training data set by an initial labeling using existing and validated product types. And if you see here, we have two sets of known product types. So V1 is the very first set that we created internally. And that is used to label the candidates for the first round of training. And the other one, V2, is an expanded version of V1, which is not seen by the model. We use that as a ground truth to evaluate how our approach works. And specifically, we actually use model to expand V1 and see how many of the new PTs, new product types in V2 can be discovered. And now let's look at the classifier we're using. So the classifier is trained in a way that it emphasizes the positive cases, and it's called positive only distance training, which is introduced in the same work of the phrase mining we just looked at. And it uses a random forest model with each base learner trained on a so-called perturbed training set with positive examples sampled from the known product types and the negative ones sampled from the candidate pool. And it's perturbed because the negative ones are not always true negative, as some of them are undiscovered, but good product types that the classifier tries to identify. And we independently build samples of positive labels from existing knowledge bases and the negative labels from the candidate pool, and train a number of base classifiers. We then aggregate the prediction from those classifiers. And this independency actually helps to reduce the noise from the negative labels. And after the training, the classifier assigns a score to all candidates. The higher the score is, the more likely it is a valid product type. We didn't follow a typical active learning data selection strategy that selects the most informative data points for labeling, because in our scenario, the classifier is cost sensitive. So meaning approving an invalid product type could be more damaging to our customer than missing a valid one, as many downstream applications are sensitive to the correctness of the ontology. So we have to ensure any new product types are manually verified before releasing. Given that, and in the meantime, we want to maximize the throughput of our domain experts, we practically select the highest score candidates for manual labeling. And for the same reason, we ask the domain experts to be conservative when they're approving any new product types. Although this is not an optimal way to reduce noise, but it does guarantee that whatever we added to our knowledge base, it is confirmed and verified. And it actually helps, it actually corresponds to our classifier, which is positive only this is training, which actually kind of echoes why we use that classifier. And here I want to show some results. So we test our approach in a simulation that keeps expanding V1, and we compare our results, let's say V2 prime, to the actual V2, and we see how much V2 prime and V2 overlapped. We measured our performance of the proposed framework by the effectiveness and the coverage. So the effectiveness means how many new product types we discovered, and what is the precision of our discovery proposal. And in terms of coverage, we actually look at the completeness of the discovered product types. Initially, we found 50% of the V2 product types are discovered. And after some cleanup with experts' help, we actually boost the coverage to over 70%, which indicates that the accurate domain experts' feedback is very beneficial to our model. In addition to those offline lab metrics, we actually did an online test of 150K queries of one category. Then we actually observed a significant increase in all key search metrics, including click-through rate, add to cart, and conversion. Okay. And to summarize, we actually propose an active learning framework together with positive or only distance training for product type discovery that leverage domain experts in an efficient and a scalable way. And according to the boosted coverage result, we propose our next steps. So one is we want to design the denoise procedure and add it as an additional component into the framework that would improve the completeness of our model. And second, we're going to focus on improving feature engineering for the classifier by exploring more textual and image data, which I haven't covered much in this presentation, but feel free to include, feel free to check out our papers if you're interested. Yeah, and thank you very much for everyone for listening.
Thanks so much, Becky. So the next talk that we're going to have is from Becky West, Interpretable Methods for Identifying Product Variants. Becky is a data scientist who works on online recommendations at the Home Depot. She enjoys applying new data science techniques to solve customer problems and collaborating with other experts from a variety of fields at the Home Depot. I'll let you take it from here.
Great, thank you so much. All right, so as mentioned, I work on recommendations at the Home Depot. And if you're interested in any of the projects that we work on, actually the best place to learn about that is on our website. Almost all of the recommendations that you see there, including product recommendations, project guides, content, other recommendations like that, are projects that our team has worked on. So today I want to specifically talk about a project I worked on for identifying product variants. So if you take a look at our website and navigate to one of the products, you can see that we have different variants available that are kind of easily surfaced here in this experience. So if you're interested in pull-out kitchen faucet, then maybe you were originally looking at a polished chrome version, but perhaps a different color or finish might go better in your kitchen. So you can see all of these different finishes that we have available here. So obviously, this is an important experience for the customers. It allows customers to easily see the different variety of options that we offer for that particular product and navigate between them without having to do an additional search and kind of hunt through the catalog to find those different options that are available. A lot of these products are identified manually by a number of different teams at the Home Depot. But occasionally some different products might get missed during that manual process. So for example, we may have another blue faucet that's available in the catalog, but it doesn't show up here if it's not been manually identified. So what we wanted to do is to create an algorithm to sweep through all of our products and kind of find those that are missing and could be added in to this experience. So that was the algorithm that I worked on. And as part of designing this algorithm, we had a number of different considerations to keep in mind. One is that we wanted really high both precision and recall. Since this is a really visual, highly used feature on the website, we don't want to make a mistake. And so if you're looking through and picking out different colors and you're looking at faucets and all of a sudden you switch to be looking at a hammer, like that doesn't make sense. It would be a really bad experience for the customers. So that's why the precision aspect of this is so important. And also recall, since this is a really valuable experience to customers, if we do have additional options available to them, then we want to make sure we're showing all of those. So both of these aspects were important in picking the algorithm. Additionally, we wanted our algorithm to be very interpretable. So this is not always as important in every situation, but for this particular situation, it was. We're going to be working very closely with other business partners at the Home Depot, and we wanted to be able to incorporate their domain knowledge and also answer questions if anything went wrong to kind of explain why it went wrong and then discuss how can we fix this. And then finally, we need this algorithm to work well for different types of products. Jackie introduced that idea of we have a lot of different types of products at the Home Depot, and different products have different considerations. So for example, when we looked at the faucets, we may want to pick out different colors, but when you're looking at a different product, the color may not make as much sense. So for light bulbs, instead, the customer may want to switch between different numbers of light bulbs in the pack, or maybe the color temperature. So we need our algorithm to be flexible and pick up on these differences for the different types of products. So the approach that we settled on, given those considerations, was one of constrained clustering. So we're doing clustering because we're grouping together these different products into the variant. And then we have several business-specific constraints that we want to apply to our clustering rules. So the features that we used for our constraint clustering were the product category, which is like the type of product that we're looking at. Here, it's a little bit more granular than what Jackie was talking about. The brand name, the product title, and also the model number. So for the product category and the brand, we actually do an exact match. For example, for product category, you don't want to group together a hammer and a faucet. Those are not variants of the same product, right? Instead, we're only grouping the faucets together, and really that specific like pull-out kitchen sprayer faucet goes together. It wouldn't go with like a bathroom faucet or something like that. And then also the brand, typically when users are switching between different variants, they want to stay within the same brand. And then we looked at two other features as well, the product title and the model number, and how we matched on these was a little bit more complicated. So for the product title, what we ended up doing was more of a fuzzy match, where we used some natural language processing rules to clean up the title, and then we'll match on that cleaned title value. So you can see some of the rules that we use here listed below. Some of them are pretty standard natural language processing, things like removing punctuation, removing some noisy tokens, removing numbers and units of measure, that sort of thing, things that are pretty noisy. But we also came up with some specific Home Depot rules. So we had our own dictionary to match different synonyms and other types of tokens that are kind of home improvement specific dictionaries. And then finally, we also removed and cleaned up tokens that are category specific based on how the product should vary. So a lot of those different variant information is included in the product title. So in the case of a faucet here, again, we're switching by color. So here we're looking at vibrant brushed nickel. That's there in the title, but as we're cleaning it up, we want to remove that color information. And again, this is specific to the category. So while we're removing color from the title in faucets, in the case of light bulbs, we might be removing things like how many items are in the pack or the color temperature. And this allows us to make our algorithm really specific to the different categories that it's looking at. So once we've removed all of the noise, cleaned up the title, and removed the information that we want to vary by, then we can do a match on those cleaned up product titles. So in addition to looking at the titles, we also want to look at the model numbers. So one thing that we found was the model number for a lot of different types of products encodes information about what that product is. So in the case of kitchen faucets here, you can see that the different variants of the faucet have almost exactly the same model number, except for the very last piece. And the last two characters for this model number here are actually encoding information about the color, which is what we want to vary by. So what we want to say is, okay, almost the entire model number should stay the same, but just at the very end, it's okay if you swap out a few of those characters to maybe switch from brushed nickel to polished chrome or something like that. And so in order to handle this, what we used is an edit distance, a character-based edit distance for these model number strings. And we had a couple different rules that we allowed. So we allowed insertions and deletions to say, okay, maybe there's a base product, and then there's variants built on top of that. So in the case of light bulbs, there's a base, you could buy one light bulb, Or you could buy 12, and the 12 here adds in just a couple of additional characters saying this is a 12 pack. Or in the case of faucets, we allow substitutions. So each faucet has a dash and then 2 characters representing the color, and you can swap out those last 2 characters as a substitution at the end. So using the edit distance allows us to say, okay, these small modifications are okay, but the majority of the model numbers should stay the same. And doing a little exploratory analysis, we did find this was the case for most of the types of products that we sell. Items that are actually product variants of each other do have that small distance in between each other. Whereas if you compare items that are not at all the same, then they're much further apart in the edit distance. So combining these 4 different features, we were able to put together the rules that we use for clustering the items together. Again, the exact matches on the important things like the product category and the brand. And then we use these information-rich fields of the product title and the model number. But we had to do a little more clever rules before we could do a matching on these 2 features. All right, and so before we decided on this, we did want to check out some different options. So we looked at a number of different options. So I just want to talk about why we believe this was the best way to go forward. So in terms of constrained clustering, we looked at different types of features that could be included. The 4 that I showed you before were the ones that we settled on. But I just want to call out adding that product title was actually one of the key pieces of information in our experimentation that we found. And then we also compared against other classification baselines that are used within the industry. In particular, we looked at a random forest based approach that used a couple of more generic features, some different ones that we had than we had looked at before. So when we compared the random forest-based classification against our constrained clustering, we did find the classification baseline had a slightly higher precision. But in this case, there are a few downsides. So one was that when it did make a mistake, it was much harder to explain what that mistake was in a random forest situation, as opposed to our more rule-based clustering. It was much easier with constrained clustering to explain, okay, this is what went wrong, this is how we can fix it. And that was a very important consideration in our case. So we're willing to accept a little bit of a drop in that accuracy and that precision in order to get the interpretability. Also, the constrained clustering had a much higher recall, so we were able to find a lot more products in our catalog. In the case of the classification baseline, a lot of the products we found were actually ones that had already been manually identified, so it didn't bring a lot of net benefit to us, whereas the constrained clustering did actually find a lot of new products that we could add in to the product variant experience. And then finally, we found that the constrained clustering tended to work across a much wider variety of categories. So the random forest typically worked well on much larger categories. So it got a lot of products in the large categories, but it didn't work well on the smaller, more niche categories. And so it wasn't an approach that we're able to expand across a lot of different types of products. Whereas the constrained clustering did generalize much better to a lot of those more niche categories, which was something that was important to us. And then finally, I'll mention that the within our experiments for the constrained clustering options, one of the most important things we found was that product title. That's a very information-rich field. And so kind of cleaning that up and making sure it was a really usable feature was something that ended up being very important. When we did not include the product title, both the precision and the recall dropped dramatically. Okay, so thanks for listening, and I'm happy to take questions.
Thank you, Becky. Thanks very much. I'm going to add Jackie back here. Here, Jackie's here. I can see you, Jackie. Hello. Okay, thank you both, Jackie and Becky. We have a lot of questions from our attendees, so I'm just going to pick a few here from people. So Asha asked you, Jackie, is there a possibility we can contribute or view the Home Depot's source code? Is it open source?
Unfortunately, our code is not open source because that contains sensitive data, and actually our the paper we published has a patent already filed for it. Yeah, but we do contribute to some public algorithm, but not specifically for this paper. I hope that helps.
Okay, thank you, Jackie. And Becky, so someone asked, by exact match and fuzzy match, are you talking about hard and soft clustering?
Yes. So we think of it more as a constrained clustering, with the hard constraints being more the exact match, and yeah, the softer constraints would be the fuzzy match. Exactly.
Thanks, Becky. And Jackie, Jessica asked, in terms of this product type search, how do you handle typos?
Yeah, we do have several algorithms when a query comes in. So we have a spell correction algorithm that trying to identify the typos and map them to the correct ones. And it's based on custom behavior and also a couple of text-based models.
Okay, and thank you, Becky. Can you talk more about the cost of your classifier, and are you trying to minimize false positives or false negatives?
Sorry, was that for me?
Oh, that could have been for Jackie, was it? Yeah, no, sorry, Becky. I think that one's for you.
Oh, okay, great. Yeah, so what we actually did was since we had such a high precision requirement, was we only accepted results for certain categories that met that very high precision requirement. So the goal was to find as many different categories as we could that would have very high precision within the category. Hopefully that answers the question.
Yeah, thank you. And another one here for you, Jackie. Mm-hmm. Somebody wants to know, how many models do you deploy in production in a month?
Well, I think it really depends on the phase of models. So for example, I have projects that I have like about several months of model development process. And for a model, we have like kind of interactive process with development model and human validation, the retraining the model again. And once we are good, we're confident about our model results, we'll start with the deployment. But it really depends on the model complexity and which platform we are deploying the model, and the frequency. Yeah, I don't have this number on top of my mind, but we usually the projects can last from 3 months to 6 months, and the deployment is usually the last mile we're trying to pitch for. Yeah, hope that helps.
Yeah, great answer. Thank you, Jackie. So Becky, this one's for you. So Joanna asks, are you using basket analysis, please?
Not for this particular algorithm. So for other types of recommendations, we take different approaches, but for the product variants, it's more about the product information than it is about the customer behavior.
Thank you, Becky. And we just have another question in that just popped in there from an anonymous attendee. So they asked, how do you deal with third-party data?
That's a great question. So for we look at a lot of different types of data sources for recommendations. So as I mentioned, the product information is one important one. The customer first party data is also important. And then for some algorithms, for things maybe like personalization, that would be more where we would be including that third party data. If we could include information about, is someone a pro, or more personalized information about that user, then that would be something we might bring in more for personalization touch.
Thank you, Becky. And Jackie, there's one here for you. So there was a famous data mining example where someone found that if a man buys diapers after 10 p.m., he will also be more likely to buy beer. Is there a similar example of a surprising find for the Home Depot products?
So I think that's more like a basket analysis type of question, where customer searched product type A are more likely to search B in a given time frame. So for the study we've done for the product type, we didn't look at the co-appearance or frequency of a co-usage of the product types. But I believe there are other analysis we have done that actually indicate the frequency of usage, and that's more on the recommendation side. I think Becky might have some insights to bring in.
Yeah, one thing I'll mention is that actually something we sometimes try and avoid. For some of our recommendations that do use customer behavior, we do sometimes see these unexpected kind of weird relationships between items. And sometimes that makes you double think and say, oh, is there a reason why this comes up? But other times it's just like a little bit of noise in the data. And so we actually do spend quite a bit of time trying to prevent weird relationships from showing up in our recommendations. So we may have some filters that block, say, that say only these two categories can be recommended together, and that sort of thing, to prevent the like weird noise. But in other cases, it may be a true correlation, and that's something we look into more.
Awesome. Well, that's a lot of questions we had in there from all the attendees. Thank you very much, everyone. And a massive thank you for Becky and Jackie. So now that we're coming up to a wrap up of the events, and I just want to take this opportunity to thank the whole Home Depot event, the whole Home Depot team that's involved in this event. And big shout out to our speakers, Becky, Jackie, and Estelle for today. So I'm going to invite Claire now to the stage, who is going to announce our spot prize winners.
Awesome. Thank you, Sapphire. And yes, thank you, speakers. That was awesome. And then thanks to everyone engaging in the chat. We had amazing questions. We had so many chats back and forth, so that was awesome. But the two winners are Asha George and Jerika Tucker. So congratulations. I will be getting your information from Women Who Code to send you an email so I can give you your prize.
Thanks so much, Claire. We really appreciate it. It's been super exciting today. Thank you to all of our speakers. If you want to get involved with Women Who Code Data Science, womenwhocode.com/data science. We also have a Slack channel that I think Trishti is going to drop in the link. Oh, it's yelling at me. Just to let you know what's happening next in data science at Women Who Code. We are launching a stats and data science webinar next Saturday. So here's the overview of everything. You can register at this link here at the bottom. And there will be more information about that on Women Who Code Data Science events page, as well as in the Slack channel. You can also find us online, Twitter, Facebook, Instagram. Check it out, stay up to date. Thanks so much to everyone for coming and contributing and asking great questions. Thanks again to the speakers. I think that's about all. Have a great night, everyone. Afternoon for Eastern Standard Time. I'm currently in Norway.
Oh, wow. Well, thank you so much.
Thank you, everyone. So many people in the chat saying thank you. Thank you all for attending. And a huge thank you again to the Home Depot team.